And yeah, great. And then we will, so I've got a couple of minutes. I'm going to just go through the structure for the evening and the rules so that everybody's up to date for those who haven't joined us before. Tonight, we're going to be on the Process Safety Forum, and we're going to be discussing getting a grip on functional safety. And Nick's going to be answering your questions live. So be ready to get typing your questions so that he can answer them for you. Remember that this session is being streamed live to YouTube, and it will be available for playback on the YouTube channel. So just be mindful of what you say and be respectful. The other thing to bear in mind is that both Nick and myself and anybody else who joins, we are volunteering our time. Nobody's getting paid here. So again, just be respectful when asking questions and giving comments, being mindful that we are all professionals here volunteering our time in the effort of raising awareness for process safety. With regards to the technical setup, if you're having any problems with Zoom, just give me a ping on the chat and I'll try and resolve them. I've already had a couple of technical issues which we've resolved with Nick today. And then also, please use the opportunity at the end to give feedback, because that helps make future sessions. So at least the next 4 sessions, the topics that I've selected are ones that have been given through the feedback. So your feedback is useful and it is used, so make sure that you give it to us. I think we still have a few minutes now. I will stop sharing this. Yeah, so Nick, what's the weather like there by you?
Well, as you can see, it's nice and sunny. The breeze is there. I've got my shark repellent on, so I'll be fine. I'm in the northeast of England. It's been a nice day, actually.
Yeah. Yeah, I'm down south. It was really lovely today. The sun was out. It was cold, but it was lovely. Nice change from the wind and rain. Yeah. They said 10 days or so of this.
Really?
10?
I can live with that.
Might have been Thursday this week or Thursday next week. Well, anyway, whatever it is, it's good for a few days. Okay, well, we've got just 2 minutes left. So Nick's let you know that it's a very nice background. Almost as good as the photo on LinkedIn with the shirt. Hi, Nick. Yeah, so Nick, obviously you can hear us okay and you can see us both okay. If you can just give us a little text. Oh, all good. Right. Okay, well, we've just got 1 minute left to go. So Nick, unless there's anything you want to add before I kick off on the slides.
No, you please carry on.
Excellent. So we'll share again. So welcome everyone to the Process Safety Forum today, where we're going to be discussing getting a grip on functional safety. We're joined by Nick Howard from Six Engineering, and he's going to be giving us specialist advice on functional safety and answering all your questions. The agenda for tonight, we're going to give a quick introduction to the topic and to the presenters. We're then also going to open the floor for questions as per normal. We'll have about 45 minutes for questions, and then we're going to wrap up and I'm going to give an announcement for the next session. The next session is going to be in a month's time, because I'm working on the basis that we should be embedding the learning. So having a different topic every week might not give us the chance to embed some learning. So I'm taking a different approach, and we can see how that works for a couple of months. So before we do, well, we'll do our introductions first, and then we're going to do a quick poll, and then Nick can give his presentation. Is that all right, Nick?
Yeah, that's fine. That's fine.
Okay, so Nick, if you can give us an introduction to yourself, where you're working, and what your specialty is.
Okay, so originally I was a chemical engineer, but don't tell anyone. I moved over into tech safety in about 2010, 2011, and I sort of quickly got involved in functional safety, but I didn't actually take the qualification until 2016. And since then, it's been pretty much full on functional safety. And yeah, that's kept me pretty busy. And you know, what you actually learn on the course is just a small part of the overall functional safety requirements.
And you're talking here about the course, either the one that is run by Exceeder or the one that is run by TUV, right? Those are the courses you're referring to.
Yeah, there are a few out there. I personally did a TUV one, but there are others.
Okay, and my name's Louise Whiting. I've done the course as well, but I did the Exceeder one, and I'm resitting the exam later this year, hopefully to pass on the second time. But it is really a tough exam, so well done, Nick, for getting the qualification. And also, just to say about the qualification, it is also covering your technical experience. So for Nick to have been able to get the qualification, he has to have an extensive background in this area. So that was also tested within the qualification. You can't just do the exam. So I'm going to do a quick poll just before we go into the presentation so that Nick knows how to angle the presentation. I'll just give you guys a few minutes to respond. It looks like a bit of a mixed bag. If I end the poll now, and if I share the results. So if you can all see the results, most people have some idea of what this is. There's some people who don't. And then there's a few practitioners on the line. Okay, Nick, so I'm going to give you the mic now so that you can go through the rest of the slides.
Okay, thank you very much. I'll just move my panel so I can actually see what I'm looking at. There we go. So just to start off then with the basics, what is functional safety? So what we want to do is to use some instrumented systems to provide a quantum of additional risk reduction where the process isn't safe enough. So that is to say that we've done our hazard and risk assessment and we've determined that we need additional protection there, and we need a specific amount of additional protection, and our system needs to be capable of doing that. So most people come across functional safety in the form of a SIL rated trip. So for example, you might be wandering around site and you see a level transmitter, and on the cable to it, it says SIL 1, which is what I've just seen this afternoon. Functional safety has been around for several decades. There's been a couple of iterations of the standards. Unfortunately, there's many instances of getting it wrong, but it's not as difficult or as complicated as it seems, and if you follow the rules, all will be well. So typical problems I find when I go to sites, usually after they've had a visit off the HSE, the responsibility for functional safety lies with the site manager, but there's no real ownership. So you ask anybody who's responsible for it, and well, it's the site manager. It's usually managed by the electrical department because it's made up of cables and electricity, and they make sure that the trip's calibrated and tested, so they do their bit. But by and large, there's no functional safety management system, and if you don't manage it, then how does it get done? What I find quite often as well is that nobody knows quite how many safety instrumented functions there are on site. What SIL they are, perhaps they think it's SIL 2 or SIL 1, and they don't necessarily know where they came from. And that's not to say that somebody installed it but they've moved on. It's to say that they can tie the protection back to a particular hazard that was identified in Hazardous, for example. And another thing I find a lot is that there's no safety requirement specification, or that if there is, it's been put together and there's lots of holes in it, or just blank spaces. Now, it sounds familiar to me, perhaps it's familiar to you, but not to worry, there is a path forward on this. So I've put down some tips of how I would advise people to start getting a grip on functional safety. And I think the most important thing is to start preparing a safety requirement specification for each trip that you've got. And the functional safety standard IEC 61511 lists 29 items that you need to address on it. And for me, I think the most important thing on a safety requirement specification is a reliability block diagram. I like to put them in. You don't have to, but I think a picture paints 1,000 words. I think you then need to go and you need to undertake a site survey. And this is particularly important because if you don't know what's out there, then how do you manage change? So I think do your site survey, note down the equipment make, model, serial number, draw your reliability block diagram from there, and you'll end up with a SIF inventory, as I like to call it. So that's what makes up my SIF. I think it's a good idea to collate site information such as your HAZOP, your SIL assessment, cause and effects charts, any other relevant documentation, and put them in a folder. So prepare a dossier. It just makes it so much easier if everything's in the same place. Obtain safety manuals for each device. SIL rated kit comes with a safety manual, and you'll either have a copy of it, or you can probably either call the manufacturer or go on the manufacturer's website. There will be something floating out there, but obtain it because you'll need it to do the next bit, which is to prepare SIL verification calcs. And I would recommend that you use the simplified equations just because it makes it easy. And if using the simplified equations, you're very close to your limit or you don't meet your requirements at all, your targets, then you can look into it further, but you probably do have a problem and it's going to be beyond you to solve it if you're not a functional safety practitioner. So that's when you need to ask for some help. And lastly, I think you need to undertake an FSA4. So it's a stage 4 functional safety assessment, which is something that's done during the operations and maintenance phase of the SIF, the safety instrumented function, or a TRIP, as a lot of people call it. And what the FSA4 will do is just identify where your gaps are. So what are you doing and what aren't you doing? And then once you know where your gaps are, you can start addressing them. So that's for the short term. In the longer term, I think it's really useful to identify and engage with a local independent functional safety specialist. And we are all over, there's plenty of us out there. And the reason why I say a local independent functional safety specialist is because a small one-man band, for example, will give you their entire focus, and that's probably what you're going to need. They don't have massive overheads, so it's not going to be cheap and cheerful, but it's going to be cost effective. And they will help you do number 2, which is to prepare a functional safety management system. And it's really important. In fact, I think it's vital that you obtain site management buy-in. It's got to be done from the top down. And you need to clearly communicate roles and responsibilities so that those people or those positions that you allocate roles and responsibilities to are aware of what they are. It's very useful to also send someone on a functional safety engineers course for safety instrumented systems. That will get you a long way to being able to help yourself, which is really what you should be able to do. You need a copy of the standard. IEC 61511 is for the process industries. You could get a copy of 61508, but good luck reading it. You need to start doing some functional safety planning, and you need to ensure adequate resources are allocated. The first part of that is if you don't plan it, then it doesn't get done. And if you don't allocate adequate resource, then again, it can't get done. And so it slips, and then all of a sudden we're 5 years down the line and we still haven't done what we were going to do. So in summary, it needs to be supported from the top down. The management need to buy into this and really support it, allocate resources, do the planning. Documentation is key. You need to be organised. I recommend to everybody to put together a SIF dossier for each SIF. And this helps because when the HSE come around, you've got some proof to show them that A, you're organised, and B, you've done your homework. Get some competent local support. Like I say, there's functional safety engineers all over the place. You can come to us, but there are plenty of others. If it doesn't get planned, it doesn't get done. That's a bit of a favourite of mine. And last but not least, your safety requirement specification is absolutely vital, and you need to complete it.
Yeah, so I would say, Nick, that you've covered all of the relevant points from the standard. I must say that a lot of people may find the standard a bit daunting, considering the number of parts and the number of pages. But as you mentioned, if you've got someone who's qualified to guide you through, it does become a little bit easier than the daunting task of the number of pages that it seems to be. Right, so I'm going to stop sharing the screen now. We've already had a question come in on the Q&A. So our question is, what are SIL verification calculations, and what is a stage 4 functional safety assessment?
Okay, so I'll start with the calculations then. So what you are trying to do is prove that the design that you've put in, which might be, say, a sensor, transmitter, a logic solver, and a final element. Final element could be a valve, for example. And what you're trying to do is you're trying to determine whether the likelihood of that failing, that system failing, when you need it. And it needs to fail less often than your target that you've allocated in your SIL assessment. So, for example, for a low demand system, if you've got a average probability of failure on demand target of 0.05, which is right in the middle of SIL 1, you need to have a failure rate that's lower than that. So that's what your SIL verification calculations are for. And depending on what your architecture is, so perhaps you've got 2 out of 3 voted sensors, you've got a couple of logic solvers, and you've got a couple of final elements, and only one of them perhaps needs to close. There's different calculations for all those different architectures. A stage 4 functional safety assessment is it's an assessment of what you are doing with regards to functional safety during the operations and maintenance phase of your SIF. So there are several life cycle phases that you go through. So one is hazard identification and risk assessment. One is allocation of functions to safety functions to protection layers. You've got design and commissioning and installation and stuff like that, and decommissioning. And your FSA4 sits right in the middle of it all, where you are expecting this particular function to provide you that quantum of protection that you've defined in your SIL assessment.
Okay, sorry, I was just looking for a presentation I'd done for the Safety and Reliability Society to show some of the calculations, just to help with the discussion. I managed to find a picture of the drawing, that shows you where things are. So let me see if I can pull that up, because that just might help explain the different stages of the life cycle. Share screen, this one. Okay, so you can see that now?
Yep.
Yeah,
okay, so this
it's
is
also not expecting anyone to see it or to read it, but yeah, so we're along. So you're talking here about the along here by step 14. That's where our FSA 4 is, functional safety assessment 4.
Yep.
And then our FSA 1 is just after we've specified. They're saying we don't hear. They can't hear me. Is it you can't hear me, or you can't hear Nick? Right, let's see. Let me see if I can put up the chat. Let's stop sharing. Nick, you can still hear me, can you?
I can still hear you, yes.
Yeah. Okay, let me just see. Okay, so Nick, so he says that he can still hear us, so that's still now. And so Nick, so can other Nikhil. Okay, so that's fine. So maybe maybe it's just your audio. If you try exiting and coming back again, maybe you might be able to hear us again. Oh, that won't help. I'll type. I'll share the screen and I'll type, and then if you carry on with the discussion.
Okay.
Right. Whatever can happen will happen, right? There we go. Right, you carry on.
Okay, so
pointer, then let me know.
Yeah. So this is a slightly different presentation of the functional safety lifecycle than what you find in the standard. If you look in IEC 61511 on figure 7, in IEC 61511.1, that is, you'll find the functional safety lifecycle. And so right at the start, it's just a design like anything else. And really, I think for me, functional safety is a quality management approach. So what you're trying to do through each of these stages and each of the functional safety assessments is minimize the likelihood that you're going to make an error. Because the more frequently you are likely to make an error, then the less likely your system is going to work when you need it to. Now, obviously for SIL 1, then the amount of error that your system can tolerate is much higher than for SIL 4, for example. So like I say, FSA 4 is in the operations and maintenance phase, and what we're trying to achieve there is to make sure that we test it on time, that we manage it properly, that we investigate demands and classify them as whether they're real demands, so the process needed protection because your control system failed, for example, or whether it's a spurious demand and say your instrument had a fault. So all these things are what we're looking for in FSA 4.
Excellent. Okay. I have another question from Nick. So it says, you're covering functional safety in the operational stage. To what degree should functional safety be considered in the design phase of a new plant or platform? And how about the end of life too?
Okay, so thanks, Nick. I'm going to get him back for this. So right at the start, when we're looking at the design, we'll do a risk assessment on the design, and normally on most plants that takes the form of a HAZOP, so hazard and operability study. And what we're looking for there is what are the cause-consequence pairs that have such a significant risk associated with them. So we tend to be looking at fatalities here. We may use serious injury as a sort of the bottom layer of this. Anything below that is not SIL territory, really. So we go through our HAZOP and we identify where we may have fatalities, and then we'll go to some sort of SIL assessment workshop. It could be a LOPA, it could be a risk graph workshop. We could use a QRA. There's risk matrices. And in IEC 61583, you'll find the different methodologies for determining SIL. And what we'll do is we'll evaluate the design that we've got, particularly the cause-consequence pairs that we've identified can lead to a fatality, and we'll determine whether our design is adequate, whether the risk that this poses is tolerable compared to what our company says is tolerable. So for example, we might say that it's intolerable to have the potential to kill somebody, one person, from any one cause from a design more frequently than once in 10,000 years. So if we can do that more frequently than once in 10,000 years, then we need to reduce the risk to a level that we consider tolerable. So that's what we look at during the design stages. During decommissioning, it's a little bit different. And so what happens throughout the rest of the life cycle for functional safety is we're doing a functional safety assessment sort of after the fact. So we're just checking that everything was right. What we do before decommissioning is we need to do a stage 5 functional safety assessment. And really what we're looking for here is there a reason why we shouldn't take this out? Is it protecting against other hazards? Is it as it was when we designed it? So have we managed it all the way through? So when we go out there, I recommend that you go do an inspection, a site visit, and you go around and have a look, and you look to see whether whether what's installed is what you expected to find. Because if it's not, then something's changed. And if you take this SIF out of service, then you may lose protection against something else. So the FSA 5, as it is for decommissioning, is just really for double checking before you take something out. And I think if you treat it as you would a design, you won't go far wrong, actually. It needs to be engineered. Don't just take it out.
Yeah, and also what I'd add then, Nick, is that if you are decommissioning something, you know, well, if you're taking something out of service, you really need to be thinking about whether you're mothballing, whether you're decommissioning, whether you're, you know, archiving. How are you going to do it? Because sometimes you can land up with systems which are actually still live, but the protection measures have all been deactivated inadvertently because nobody's had a look at the interfaces to see that that system is still live with hydrocarbons or other hazardous material and still needs protecting. They just don't really know, you know, if you don't look at it in detail.
So for large changes, for complex changes, I would actually start off by doing a hazard. And then you approve what you do need and what you don't need. And if you treat it like that, again, you won't go far wrong. So it's all about minimizing the chance of error. Yeah,
change management is tricky at best of times. Decommissioning makes it even harder. I've got quite a long question. It's got a couple of parts in it, so I'll probably do the first part and then come back for the second part. So this is from Tomas, related to risk assessment. So what about LOPA and multiple SIFs, which can reduce the risk for the same hazard? Then usually use the same final element, so there's no full independency. So then he's given an example, so I'll read that. For example, blockage of a flue gas on a filter. There's a SIF related with this situation, which closes the fuel gas line to the furnace. But there's also a main SIF related to the overpressure of the furnace chamber, which closes the same valve. Common sense that we should use it as a risk reducing measure, but maybe with a lower risk reduction factor. So because there's common end element, how would you manage that?
So I would say that you can use it once. Just choose one. Choose the one that does the best on the calculation if you want, but you can only choose one because you haven't got two independent systems there, and they need to be independent.
Yeah, I think sometimes with a gas supply, there can be two valves, and they can be executed by different signals, but you'd need to check your exact lineup of your system. But if there's one common valve, agree, you only take once. Okay, and then I have another question from Tomas, a question related to SIL verification process. How do you manage a ridiculous reliability data coming from some SIL certificates, even from well-known certification bodies, like dangerous undetected failure rates of 1 fit for a final element? So you might have to cover what SIL means, because I don't think we've explicitly said that. What's a fit? And then what would a reasonable fit be, and what does 1 fit mean?
Right, okay.
Sorry.
Write this down. So
I can do SIL. So SIL is the safety integrity level required. The fit is, if you do fit and then 1 fit, and then what should a fit be, and what does this mean if you take ridiculous?
Okay, so a fit is a failure in time. So that's 1 failure per billion hours of operation. And you see this quite a lot in especially for relays and things like that. You see this sort of data. It's basically a failure rate. It's nothing different to failure rates, and you can swap one between the other. In answer to the part about ridiculously low ones, what I recommend is that I put an order of magnitude penalty on manufacturers' failure rate data. And the reason why I do this is because when your manufacturers test their equipment in order to obtain a failure rate, they do it in the most pristine laboratory optimal conditions that they possibly can, because they've got a product to sell. So they want to get the best out of it. Your plant will not be pristine. It won't be laboratory conditions. It won't be optimal. it's probably going to be noisy, dusty, grime everywhere, things like that. And so you're probably not going to get that sort of failure rate. And so I would add an order of magnitude onto the failure rate there. I would multiply it by 10. And I don't think you'd be too far off if you did that. I think if you used the data directly from the manufacturers, I think you would have a hard time justifying that your system is as good as that.
I think the other thing to bear in mind is that if you have several components, you need to take the weakest link. So even if your relay has a extremely reliable data set, it might actually be your end element, might be your valve that is less reliable. And so therefore that loop then is the lowest common denominator.
So what you're talking about there is hardware fault tolerance. And it's to do with the safe failure fraction, which is the number of safe failures compared to the total number of safe and dangerous failures. And there are some rules about that, but you won't find them in 61511 because they're in 61508, handily enough. As an operator of a plant, you don't really need to know that. As a designer, you absolutely do. So you'll have to go fishing for that information, but it is there, and it's quite understandable, actually. It's quite clear.
And I think also the key here is whatever you do decide to use is just documented well, so that if ever you need to challenge anything because things have changed and something new happens, you know what you did and you can go back and fix it, right, if you need to.
Absolutely, yeah, absolutely.
I've got a question from Nick and then a question from Amir. So Nick is, should companies carry out an audit on themselves before an HSE inspection, and how should they do this?
I think it's wise to do so. You don't have to. And I think if you get your local functional safety engineer round and ask them to come and do you an audit, then that will probably give you what you need. And as an auditor, what we're looking for is how well are you meeting the requirements of the standard. So we'll start right at the top and we'll say, let's have a look at your functional safety management system. And then we'll start going through the FSMS and asking the roles, the people in those roles that have allocated responsibilities, what do they understand that their role and responsibility is for functional safety. So we're looking for holes, really, and we're looking. Then for me, I want to try and give some advice on how to fill these holes. Not specifically an auditor's task, really, necessarily, but I think you need to add value, and so when I do an audit, that's what I do. Yeah,
it's very easy to leave an audit with solve world hunger and peace, but it's much harder to give the targeted actions you're mentioning there. So it's much, if you can find somebody local to you who can give that targeted advice, it's really useful actually taking it forward. And I'm talking from experience of operating. If you've got unclosable actions, it becomes very difficult to manage. But if you've got smaller chunks, then it's much easier to action. Right, next one is from Amir. Is there anything in the standards regarding what to do when there is no OEM failure rate data available?
Okay, so Exeter has very helpfully listed a load of generic failure rate data on their website. And that's where I would recommend that you go for generic failure rate data if you can't find your OEM data. And just to make it very clear, you don't necessarily have to have a SIL certificate for equipment in a SIL loop, but it can't be more than SIL 1 if you do so. There's a grandfather clause in there, and that allows you to use older equipment or to determine your own failure rates, but I think it's getting harder and harder to fulfill that, to be honest. But like I say, Exeter have a very good database of that, and it's available free online, so anybody can use it.
Okay, then Nick, I have a question. So in the standard, it does encourage you to examine your failure frequencies at your facility and compare them to the ones that you've used or assumed in your design. My general practice is that if I'm trying to assume that something's more reliable than what the industry average is, I would need really good evidence. And so I'm very unlikely to make something more reliable. But if I'm finding that, for example, at my site, that a certain type of pressure transmitter is less reliable, I mean, it might be something because sand is getting in, or because, you know, I'm in a salty environment and others were in a different environment, then I would make it less reliable. But I generally won't make it more reliable. What is your take on that? And when do you change the failure rate data based on site experience and what they've seen?
To be honest, I've never seen it done. I've never seen anybody challenge any failure rate data. Larger companies may have their own databases, and it may be that they've collated this information from their multiple sites around the world. Whether that's statistically significant or not is down to them to argue. So for me, the key is your demand rate. So what were the assumptions on your demand rate? Did you assume that there would be one demand every 200 years? Because if your plants last for 50 years, then you've got 4 plant lifetimes before you should see a demand, really. And obviously it can occur at any time, but we're talking that kind of frequency. So if you had 2 last year, then obviously, you know, there's something wrong there and you need to investigate it. So I think arguing about failure rate data isn't going to get you very far. I think you really need to focus on your demands.
And then another question that I often come across is, you know, have I really assessed the consequences correctly? So what is the guidance about defining the consequences before we're looking at the safeguards, you know, so that we make sure that we put it in the right category?
Right. I think this is a job for your hazard study team. They're the ones that are sat around the table evaluating all the information that's available to them in for example, a hazard study, and I think they're best placed to make that judgment. So if they say that this is the consequence, then I don't see any reason to challenge that.
Okay, I've got another question here from Nick. So how often does the HSE carry out a functional safety audit on a typical facility?
They don't tend to carry out audits. They tend to come and do interventions or periodic sort of inspections, and they'll come and talk to you and ask you how you're managing so on. So I don't know whether there's any particular frequency. It just seems to be a sort of flavour of the year. A year or so ago, functional safety was a flavour of the year. I think this time around it's ATEX or something like that. It tends to change. But if you're a coma site, then I think that interaction that you would have with the HSE is probably going to be more frequent.
Yeah. And when the HSE come round, so if, for example, we're talking not in the UK, how are you going to be knowing that you're meeting your functional safety requirements? Who's going to be holding you to account?
I'm not quite sure what you're asking.
So for example, I'm working in Iraq or Dubai, but HSE is not there. So, you know, and they don't have a very visible regulator. Why would we want to be applying functional safety to our facility there, you know, if we don't have anybody trying to beat us with a stick to do functional safety?
I guess it's down to what your company says is how they wish to manage risk. And generally you'll find some sort of safety report, safety case, safety document that talks about how hazards are identified and managed and mitigated on your site, and they will link that to tolerability of risk, especially if they use LOPA. It should be very clear in there, and they'll have some rule sets, and so you just need to follow the rule set. I know that there are companies in foreign countries that say, why should we do this? And for me, it's a moral thing. I think that you should protect your people so that they can go home at the end of the day. That's very important to me. And if that's not something that you do on a site, I don't want to work on it. So, yeah, I think that's why.
Yeah. I know that 61511 has been adopted by several countries as their kind of recognized industry standard. And so in some countries like Dubai, even though the regulator is not interested in it, if you have an insurer, they're very interested in making sure that you've applied 61511, because otherwise your insurance premium is going to be higher. So that's maybe a reason to apply 61511, to demonstrate to your insurer that you're managing your hazards appropriately and you're not going to burn down your facility imminently. And in the US, OSHA have recommended the equivalent US standard, which is it's just a copy paste of 61511, but it's not mandated. So, but it is recommended to take a risk-based approach and use 61511. But yeah, you know, I think everywhere is different, and it really depends on what your company standard says. But in some cases, it's useful to have that outside driver to make sure that you apply. Nick, is there anything that if we are starting to look at functional safety, maybe we haven't looked at it for a few years, is there something that we could very quickly have a look at in our documentation to see whether we have a good health or functional safety management at our site, or whether it, you know, it's something that maybe that we might need somebody to come in? Is there something that we could?
I think I would start with the functional safety management system. When was it last reviewed? It should be a live document, or live-ish, and you should review it periodically. If, for example, you've had a company reorganization since the functional safety management system was last reviewed, then it's obviously out of date, and if you can't manage the thing that manages you, then you know you're not going to get very far very fast.
Yeah, make it, that's the same point you made earlier, make sure the person who's responsible knows they're responsible and what their role is, so that they can actually do it. I've had another question from Tomas. It's another long question, so you can take notes if you want.
Okay.
Another specific question. IEC 61511 says that all equipment used to implement a safety instrumented function shall be in accordance with IEC 61508-2 for hardware and 61508-3 for software, or assessed by prior use method. What about some sort of equipment that may not have this kind of assessment or can't be done? I mean, for example, many electrical equipment that is used in a SIF, like a circuit breaker, is used to cut the power to the machine drive. There's no IEC 61508 certificate available. Do you think that a fulfillment of some specific electrical normative standard for this equipment can be judged in this case as meeting the requirement?
There is still from the machinery directive, but it's pretty sort of blunt. I think it's either you've chopped the top of your thumb off or you've cut your arm off. It's not something I use very often. I maybe use the figures from stuff that quotes it, and they'll say that this is good for SIL 2 and these are the dangerous failure rates and so on and so forth. I think that the functional safety has been around long enough, and if you've got an old system that you have no documentation for, it's time to, I think, rip it out and put in a new one. Maybe in sort of the early 2000s, when the functional safety standards were sort of quite new, even though functional safety had been around quite a while, then perhaps there's an excuse, but really I don't think there is anymore. We're in 2020, it's been a long time.
Yeah. And I think the problem might be that if you're at an older site, you might not be able to do everything at once. So you might have to take a phased approach. So it's thinking about how you manage that phased approach and what do you use in the interim. If you've been operating the system for a very long time, you probably know what the failure rate of that system is because you've repaired it X number of times over 20, 40, 60 years, whatever. So you do know a bit about it. The only caution is when you're getting to the end of the bathtub curve. I mean, if you've operated it for a long time, which I think is what you're inferring, that maybe you're approaching the end of life anyway, and it might have a much higher failure rate than.
So I think you really should apply emission time to the components that you use, and your reliability engineers will be able to tell you much more about this and whether something is still reliable or not. But I think if you're at the point where you're arguing the toss over whether it's still okay to use or not, probably isn't for SIL.
Yeah. I mean, I think when you're on an operating site, you get to a lot of situations which are not ideal, yes, but make a plan to change it. But in the interim, have a look back at what you've done before and make an assessment whether it meets the requirements. And if it doesn't meet the requirements, decide how you can manage that in the short term, which might not be ideal solution, but you might be able to. And if you decide that actually the safeguards you can put in place are not sufficient, you may then have to shut down until you can replace. But it's just making that assessment based on your company standards or the industry standards you're applying at your site. Okay, so we haven't got any more questions again, so probably another question from me. So there are 5 different FSAs. I feel, having been through the standard, that FSA 1 is probably the most important one, making sure that you have identified the hazard, assessed the consequence, and then assess the safeguards adequately. Is really important. Like, it's your starting block. If you haven't done that, then everything else is based on duff data, if you know what I mean. Have you ever attended a site where they've said, I want you to do an FSA 4, and you've gone, okay, let me see your FSA 1, and they've gone, oh, what? And then what do you do? What approach do you take with your client, and how do you manage that situation?
So what I'd be looking for from an FSA 4 is the FSA 3. And the FSA 3 should have either looked at FSA 1 and 2 or had FSA 1 and 2 rolled up into FSA 3. And that's a common thing with small projects, is they roll up FSA 1, 2 and 3. And I think the reason why they can do that is because if it's a small project, usually you've got this stuff in place already. So it should be kind of a tick box exercise, although a couple of years ago, I did an FSA 1 and FSA 2 for a well-known EPC, and these things weren't in place. And so they got a couple of failures, but they hadn't done FSA 3 at that point. So it still wasn't a failure, but it was a sharp rebuke. So I think if somebody asks you to do FSA 4 and you ask them, where's your FSA 3? And I did this earlier on this year, and they can't produce one, then there's, for me, there's warning bells going off all over the place. It was, go in and find it. Did you actually do one? If you didn't do one, then you've got bigger problems than me.
And FSA 4.
Yeah.
Yeah. I've had another question from Tomas. You mentioned emission time. How do you choose a proper value? 10, 15, 20 years? How would you choose the value?
I would look at the bathtub curve. You're going to get some sort of infant mortality there. But then how long is it? And how long do you need it to last? Is your plant going to be there a long time? But things move on, equipment moves on. It's better, it's more reliable. Perhaps you don't want something to last 50 years. Perhaps 15 is adequate. And then probably, if I was choosing emission time, it'd probably be 15 or 20 years or something like that.
Okay, excellent. Another question from me. So when you're doing the FSA 1, you're really looking into the quality of the HAZOP and the sort of the hazard risk assessment studies. What are the most common things that you find when you're looking into?
Either that cause consequence pairs aren't particularly well documented, or there's no risk ranking. And I think the risk ranking is vital, and the reason being is, again, just going back to what I said about the people in the room. When they do the HAZOP, are armed with all the information that they need to make a decision. And if they're not, if that information is not there, then it really makes life hard for everybody else down the rest of the line. And it's a common occurrence, to be fair. It is a common occurrence. HAZOPs aren't as good a quality all the time. So. No,
that's right. It really depends on who you have in the room. We did a process safety forum on this a few weeks ago, and there is a big variance in HAZOP quality, and depends on the facilitator as well. I've just put up a picture of the bathtub curve so that so that people can see it. I don't know if you'll just talk through a couple of the points here that you were mentioning before, so it's easier for people to see.
So I would, for the failure rate, I would be looking at the middle part where it's more or less constant. And I think that's pretty much what the standards sort of tell you to do.
And this is what you were mentioning here, between the sort of a kind of a little bit of the representation of what the manufacturer might say is the failure rate, and what actually your observed failure rate is might be different to what they say. And then the reason that you get a lot of failures at the end is because of the wear out. And then the reason you get a lot of failures in the beginning is because of manufacturing or other defects during the making process. Yeah. Okay. And then this time, as you said, depends on, it's specific for each component, right? That, you know, how long it's in infant and how long it's in, you know, how long is it constant? So another thing that I've seen a lot of is when equipment fails in an unsafe mode, i.e. you don't even know it's failed, and then it remains in a failed state for a long time. How do you take account of that in the assessment, or what could you do to pick it up when you're in the assessment stage?
So what you're really talking about there is unrevealed failures. Something's gone wrong. It's failed to a dangerous state and you don't know it. So perhaps, say for example, your valve is stuck. It's stuck open when what you need it to do is to close when it's needed. It's a bit easy for a valve if you operate it quite often, then you'll know whether it's stuck or not. But let's say that you don't. Let's say it's a shutdown valve that's between sections of plant or something like that. You should undertake a periodic proof test, and it's very likely that you will do one every year. And certainly when I do SIL verification calcs, I start off with a default proof test interval of 1 year. And it might get less frequent than that, probably not. To be honest, you don't usually see it going up to 2 years. But depending on how good your preparation was during your HAZOP and SIL determination, and if you actually did one at all before you made your changes, you might find that it goes to 6 months or 3 months or perhaps even a month. If you've got a proof test interval of a month, you really have got things wrong and you've made a rod for your own back and you really need to sort it out. And so the purpose of the proof test is to reveal any unrevealed failures. So what you're testing is for the whole SIF loop to operate as you would expect it to. So perhaps you'll create a demand, say by injection of a signal, or you'll raise a level or lower a level or something like that. It's important, I think, to point out though that when you're doing your proof test, that at no point should you put your plant in a hazardous position.
So one of the examples I saw was an oxygen analyzer. So it had a membrane over the analyzer, and it had a fluid behind the membrane. And what it did was it relied on the oxygen dissolving in the fluid, and then an analyzer would measure the amount of dissolved oxygen in the fluid. But if the membrane was to fail, then the liquid that was in there would obviously dissipate, and then the analyzer would be in contact with air or whatever, you know, the lighter gas. And as a result, it would actually measure 10 times less oxygen than what was actually in the gas. Yeah. So, for example, if you were trying to get 3%, it would measure 0.3%. So you'd think, super, really, really good, low oxygen, nitrogen, wonderful. But actually, you weren't measuring anything because the membrane had failed.
Yeah.
But if you were to do a test, like you said, with the signal, you could put a 20 milliamp and it would trip. Yeah, it would trip the system or initiate the trip. But actually, the analyzer could never see that voltage or that current, because it could never measure that in a gas phase. It could only measure that in the liquid phase. So how would you identify that in the sort of, I mean, it's a very specific example, but I don't know, how would you identify that type of thing?
So when you do a proof test, it needs to be end to end if you can. I would advise as end to end as possible. and this sounds like it's one of those where it's as end-to-end as possible. I think that if you can't do a full end-to-end test, then it's really important that you look at your instrument trending. So if you expected to be seeing around about 3% oxygen, and all of a sudden, or at some point, you're seeing 0.3%, then that should ring alarm bells for you. And perhaps what you should do is look back through the trending and find the point where it dropped. And was it a sharp drop? Was it a gradual drop? What was it? And is it real? And I mean, I'm not a specialist in oxygen analyzers, but I think that you can get your instrument techs to go along and just double check everything. If you can't check it though, then you have a problem, and some instruments you may not be able to check. So you'll have to have a think about how you're going to do that one.
Yeah, it's the devil's in the detail, I think, with this. So Nick's asked the question. So are you saying we should use the observed failure rate data specific to our site? So when we were looking at the bathtub curve, rather than the average failure rate, which was on there, the constant random failures, we should use the observed failure rate.
I would say that if it's statistically significant, then yes, you should, because that data is particular to your site and all the good and bad that comes with it. The trouble is I don't think that you would probably get enough statistically significant data to be able to make that comparison. Again, I think it's demands of the key, but have a look and see what you think.
Yeah. And the other thing is, just if you're finding a difference, maybe it's more of a case of investigating it rather than adjusting your calculations.
Yeah.
Because there might be a competence issue or an execution issue or something associated with that specific task. I've got a question from Tomas again, a little bit shorter this time, so no notes, I think. I wonder your opinion about treatment of partial valve stroke test as a diagnostic, affecting the safe failure fraction factor. As far as I know, options amongst functional safety specialists, opinions amongst functional safety specialists differ on this topic, whether you can take credit of a partial valve stroke test.
In my opinion, yes, you can. But I think you should stay away from partial testing, because I think it just introduces more problems than it solves. Because people think, oh, well, we did a test on that, but actually you didn't test for all the different failure rates, the different failure mechanisms. And you'll see in your equipment safety manual, it'll tell you how to test it. And it will say that if you test it like this, then you will cover X% of all the different failure modes. So if you're going to do a partial test, then really what you need to do is go back to your SIL verification calculation and look at what sort of proof test coefficient that you've got. So if you've got a 100% perfect proof test for that piece of equipment, then all's well and good. But I don't think I've ever seen them, to be honest. And if you do a partial test, then you're going to cover even less. So I think if you're going to do partial, first of all, I would recommend you don't. And second of all, if you're really going to do it, go back and revisit your SIL counts, because it might not actually get you what you think it gives you.
Yeah, I think also looking at the design intent of what it is you're testing. If your valve is designed to prevent gross flow, it may be okay to do a partial stroke test, because you don't need the valve to be leak tight upon closure. But if you need it to be leak tight upon closure, partial stroke test isn't going to tell you anything about that quality that you needed. So it's really also thinking about what you need from that specific valve. Okay, I've got one more question from Nick. So do you think that some of the major process industry catastrophes could or would have been prevented if correct or better functional safety awareness and management had been executed?
Absolutely, no question about it. Yeah.
Yeah.
it's an obvious one. That, yeah.
Yeah. I think it's with everything, if you manage things well, and the good thing about the functional safety is it's directed at specifically managing your hazards, because you're managing the equipment addressing the hazards. If you manage it well, then it gives you good results. Okay, well, thank you very much, Nick, for your time today and all the answers to the questions. And I really enjoy your background, so thank you. Is there anything that we maybe didn't ask that you think we should know before we move on to wrapping up?
That's a good one. I think just a couple of things on SIF validation testing and just a little bit more on proof testing. So SIF validation testing is what you should do after commissioning, and it is a check that the SIF functions as per the design intent. But it needs to cover both general expected conditions and fault conditions. And what I see a lot is that there's no, what I would term, negative testing. So people don't necessarily test for fault conditions. And when I write a SIF validation test, I include an end-to-end test in that, and then that becomes your periodic proof test. But I also include in there a walk down of the SIF, so a check of the SIF inventory, and that's why I think it's important that you gather all the information that you can, because then the next time you go and do a check, if something's changed, then there should be a change record, and if there isn't, then you need to go digging to find out what it was. So I think that's about it.
Thanks very much, Nick. So as I mentioned at the beginning of the call, we're moving away from weekly calls. One of the topics that was suggested at last week's call was a failure to learn. And when I reflected on doing these calls weekly, I thought, well, we're changing the topic every week. And yeah, that's great. You know, people are getting more awareness, but we're not really giving people a chance to embed the learnings. So we're moving over to a monthly session. And in the run up to the session, I'll be sharing some information about that topic on LinkedIn and also on my website, so that you can get a good grounding in that topic before we have the panel discussion. And then halfway through the month, I'm also going to be running a masterclass so that you can get a sort of understanding. So this I'm going to learn, and we're going to be looking at applying the HSE standard for identifying leading indicators, so that you can start to actually learn from what's happening at your facility and see how that could be applied to some facilities where there were incidents. So thank you very much, everyone, for attending. Please fill out the poll at the end so that we know what you thought and what topics you might want. And thank you again, Nick, very much for attending, and hope to see you as a guest in the future.